So you'll tell me when you see my screen. You come through mtani show. You can see my screen. Is it visible?
Yes.
Okay. So now let's tackle this monster of a topic. We obviously can't cover everything, but we'll just cover the basics, because if we start to go deep into it, at a minute I'll get confused and run away. So let's start. So the diagram yenye tulikuwa nayo jana, this thing here. So we had, when we were mimicking the behavior for the call stack, we saw what was happening. So every time you call a function, so let's run this. So let's step through the code. Just a minute. So let's step through the code. Okay, so we have first on the call stack, second, third, and so forth, and so forth, and so forth. So basically, every time you run a function, you invoke a function, it's put on the call stack, which is responsible for managing your function calls. And then it's a last in, first out data structure. So the last thing that came in will be the first thing to come out. So 10th ishatolewa, 9th is gone, 8th is gone, 7th, 6th, and so forth, and so forth, and so forth. Paka tumalize. Now, there's these three things we did not talk about. There is the task queue here, the micro task queue, and the event loop. Sasa, we want to talk about these three things. So the task queue, the micro task queue, and the event loop. Before we even get to that, let's go into the browser, and then I will write some code here. Let's just have a simple HTML file that's empty. There's nothing even hapa ndani, hakuna kitu. Reload. Then let's split the screen into two so that we tuione vizuri. Okay, let's go into the JavaScript. Let's just write a console log. Loaded. Then let's open the DevTools. Script loaded. So that's working properly. Okay, so now we want to look at something. So we have looked at set timeout before. So set timeout, an API, it comes with the browser. It allows you, right, to call a callback function after a certain period of time, after some time has expired. So we'll say, we can say call this callback function after 3 seconds, and then we want to say console.log called after X seconds. So we'll wait 3 seconds, and then we should see that in the console. There we go. If we give it 5 seconds, it's 5 seconds, and then you'll see it in the console. Okay, so we basically just have a callback function that we're passing down to our set timeout. So set timeout is a function that takes in another function as an argument, as a parameter. So you can see what is going on. You're simply calling it. You're using an arrow function. Now, what if we call it after 0 milliseconds? Okay, calls it immediately, or it looks like it's calling it immediately, right? Now, let's try something. So we are calling this one after 0 milliseconds. Let's have another console log here saying script, the same script loaded. So what's going on now? We are telling set timeout to call this callback function after 0 milliseconds. And yet we are still getting called after X seconds, logging after script loaded, even though the script loaded comes after. in regards to Maliziko, the lexical position, this is the first one. So ideally, this should be the one to run first, right? Since imekuja kwanza, then the console log. But the console log, the script loaded is coming first, and then the call after X seconds is coming next. So the order has been switched. And this is happening because that asynchronous behavior we have been talking about, we said that JavaScript is not asynchronous by default. It relies on APIs to mimic that behavior. So we have the event loop, we have the task queue, and we have the micro task queue. So those three things together form that behavior that looks like it is asynchronous. So now let's see what is happening. So now in our visualizer here, you can see we have a task queue, we have a micro task queue, and we have a call stack. So what is going on here is this set timeout. When the code comes across this piece of code here, it's not going to do it immediately. It will not process it right now. It's going to realize, okay, this is a callback function. So this should be handled by the task queue. That is exactly what it's going to do. It's not going to operate on it right now because it can see the callback pattern. So it's going to say this function that we have here, whatever value we have here, we need to put it in the task queue. So callbacks are placed in the task queue. Hata kama umeiambia 0 milliseconds, itawekwa huku kwa the task queue. So, and then it will continue with the program. Itaendelea to execute number 7. That's why this script loaded is coming before this console log. Because even though we are waiting for 0 milliseconds, the waiting is not happening hapa kwa call stack. It's happening huko kwa task queue. And the task queue, the only time an item will go from the task queue to the call stack is when the call stack is empty. So after this console log has been executed, now this called after X seconds can now be pushed into the stack and now be operated on. Otherwise, haita work. So now let's look at one of those examples and go into let's see. Okay, so you can see with this example, let me just take my that I have. Simply have set out. For whatever reason, I can't copy paste by this application. Console.log seconds, then console.log script loaded. So now, based off of what I just explained, that is the exact thing that is going to happen. The script, this is going to be run before the set timeout because JS will realize this has the call button. So it probably means I need to execute this. I need to execute this fast. I need to put it in the task queue. So let's do that. So now let's go through that process. So now if you now execute the code, if we run it, okay, so we are now evaluating the program. So it's seen we have a function. So it's going through the code. It has seen that we have an anonymous function because our callback function here doesn't have a name. So it's an anonymous function. So it puts it in the task queue. And then now it will process anything else that is not going to be put in the task queue, which is the console log. So the console log will now be put in the call stack. It will now execute script loaded. And then now once it's done executing script loaded, it will now bring the anonymous function, which is the set timeout, back to the call stack, execute it, and then end the program. So let's look at that. So script loaded, we have the console log script loaded. So we are done with that. So that has been popped off the call stack. then now we put the anonymous here only when this section is empty, not before. So when this call stack is not empty, it will not put anything here. It will not try to put the task queue here. It will wait. So even if you told it to wait for 0 milliseconds, which is what it's doing because I didn't pass in a value. Yeah, let's mimic it again. The function. Let's go through the process again. To put our anonymous function, which is this function here, in the task queue. Then it will proceed, it will load, it will log script loaded, finish that execution, then run the anonymous task, which is in the task queue, put it in the call stack, execute it, called after X seconds, then pop it off the call stack. And that's it. So now let's look at another example. So let's do another one. Let's have a, that's going to allow me to do a for loop. Yeah. So we want to have a for loop that goes from 1 to 100. For loop is a synchronous operation. So it should block, it should block the call stack. You'll see, even though we have run after 0 milliseconds, this again will not run immediately. Let's actually change it and say step run after 4 seconds. Let's have a let I is equal to 0 and I, as long as I is less than 100, I plus plus console.log I. Hopefully it will allow me to do that, because if it doesn't, then we'll just use the normal browser. So what we're simply doing is we simply have a for loop that's going from 1 to 100. That's all we have. This might actually take too long because it actually kileta ako ka alert hapa. So let me give it a smaller number, 10. And then let's wait for seconds. So now let's start executing it. So remember, it will go through the code, it will see the set timeout and realize you want to use the task queue. So that's what we're going to try and do. So run. Okay. So now we can start. So when I step into it fast, it puts the anonymous function, which is the search timeout, in the task queue. Then it proceeds with the rest of the code, which is looping from 1 all the way to 9, from 0 all the way to 9. So 0, 1, 2, 3. Now, it's already been more than 2 seconds. Indio, we've already been waiting for more than 2 seconds. So how come he haijarudi? Because the waiting is not happening in the call stack. The waiting only happens after the call stack is empty. So it's not counting sai, hata ijaanza kuhesabu. It will do it after we remove everything in the call stack. Continue to count. Now it puts it. It's waited, so itaiweka sasa hapo ndani. Called after X seconds. And then it will pop it off. Can you guys see what is going on here? So let's now try it in the browser, because the browser will not do it line by line Evo. So let's come here. Let's say, let's actually take the same code. And then let's paste it in. Let's put the screen side by side. And then let's take the code, simply replace hapo. So it should already even be done. So let's refresh the page so that we see. Can you see? So even if we come and say, let's give this bigger number, you can see it's waiting even after we get to 99 in a Godzilla 2 seconds. So the 2 seconds only happens after it's sure that the call stack is empty. Let's do it again. Let me clear the terminal. Give it a higher number here, like 5 seconds. You can see it's waiting for 5 seconds. It's waiting, and then it shows up. So it's waiting after the call stack is empty. Now it waits. It waits for 5 seconds. Then it comes back because now it's sure that the call stack is empty. And the thing that is responsible for bringing things back into the call stack from the task queue is the event loop. So the event loop is constantly listening for, it's constantly checking for things that it needs to bring back to the call stack. This thing here, it's constantly looping over and over and over again. So if it checks and sees there's nothing, then it doesn't have any work to do. So it keeps checking and checking and checking. If it finds something, then it takes it from, it checks, first of all, it checks the call stack. If the call stack is empty and we have a task in the task queue, then take that task and then put it in the call stack. And then it's done. Then it listens again, it checks again. If I have a task in the task queue, take it again, bring it back to the call stack. If there's nothing to do, it just keeps looping over and over and over again. Any questions up to that point? Any questions? Any questions? Anyone with a question? Okay, so someone has a question.
A question. So let's say if you have 2 timeouts, will they wait until the main task is complete, then follow each other, or
Yes.
or they will be tasked individually?
Yes. So what will happen is now at that point it will check ni gani iliingia kwanza. So if you have 2 set timeouts, the one that came in first. So if you have, for example, if we had one for 2 seconds and another one for 2 seconds, it will still run. We check we can see we still have 2 of them, but they'll just be put into the call stack based off of ni gani iliingia kwanza. But because they are both zote mbili ni za 2 seconds, they will look like zimeingia at the same time. It's the same way. Wait, you see, so naona it's the same way if you say set timeout and then you say 0 milliseconds, inakanga ni kama haijagojea, but it actually imegojea. So let's actually do it in the upper. So let me visualize it here. So we have 2 set timeouts, both the same thing. So now let's run it. Okay, let's execute. Anonymous 1, anonymous 2. So anonymous 1 ni huyu. It's this one. It's this first one. And then anonymous 2 is this one. Now this is the next one that is put into the task queue. And then now it will go on and execute 0 to 10. Now you see what happened. It first of all put anonymous 1. The first one first ndio imewekwa kwa call stack because that's the order they came in. Remove it, then put the other one, and then that's it. Imemaliza. So you see what is happening. So when you have 2 set timeouts, at that point now it will start. But the queue is not a LIFO, it's not a last in first out data structure. It's a first in first out, a FIFO. So the first thing that came in will be the first thing to go out. Not, remember, the call stack is the opposite. The last thing that came in will be the first thing to go out. So LIFO, last in, first out. Did I answer your question?
Yeah.
Okay. So let's do one of the examples that they've given. Yeah, this one. So what it's essentially doing here is, let me take this code and put it for VS Code so that I can format it well with Pretty, and we can see exactly what is going on. So you can see I simply have a bunch of set timeouts. Right? And then I have function A, which is waiting for 1 second. Then I have function B, which is waiting for 0.5 seconds. Then I have function C, which is waiting for 0 seconds, 0 milliseconds. And then I call B. Now remember the way it works, right? So now who can try and figure out what is going to happen? So the first question is, which function out of the set timeouts between function C, function B, and function A, ni gani, which one will come back first? Which one will be put on the call stack first? Between function A, B, and C. Ni gani which one will be put in the call stack first? Because we know all of them will be put in the task queue. So let's just do that first of all. So someone has the answer. Or is it something in the chat? Let's see. A. Okay, Davis says A. Sawa. So Davis is saying A will be the first one to come into the call stack. So let's visualize it. Let's first of all put all of them in the task queue. So let's run it. Okay, now let's put them one by one into the task queue. So it's reading it line by line from top to bottom. So function A will be the first one, function B, function C to be put in the task queue. So A, B, C, right? Then D, because D now is put on our call stack, because D is not a callback, it's just a normal function. So D is now on the call stack. So these three functions will not come back to the call stack until it's empty. So until this function D has been executed, na imemaliza, they'll not be able to come back to the call stack. So now my question is, so Davis has already said A. Anybody else agree with that? So my question is, out of these three functions, which one will come into the call stack first? Let's look at this also. Nani itakuja kwanza? A. Roy also says ni A. So Davis and Roy both have. I don't know what happened. No. Just many. Oh. Anyway, let's proceed. Even thought ni stima zimepotea. You guys can see my screen. To come through. Okay. All right, so let's go through it now. Okay, so now we have these 3 tasks here. So one of them is going to come back. So one last opportunity for someone to try and figure out. So we know Davis and Roy have said A. Anybody else with a differing opinion? Okay. So let's go on. So let's step through. C came back first, not A and not B. Can anyone tell me why? Let me put them side by side. I see why Davis and Roy said A, because of the FIFO data structure, first in, first out. But in this case, that did not happen. But look at the functions very well. So function A is called after 1 second. Function B is called after 0.5 seconds. And then function C is called immediately. Remember where the waiting is happening. The waiting is happening in the task queue, right? So out of all of them, task C is the one that is not going to wait at all because we do have a set timeout, Sindio, and they are not the same. So it means when it comes here to take the one that doesn't have any, and it will be executed the fastest, which is C, because C is being executed immediately. So who can figure out the next one to come in? Does someone have a question? Who can figure out the next function that will come back? Is it A or B?
B.
It's B. We have a B. We have one B. Anybody else with a differing opinion? B. So why do you think B will be the one to come back? Do you think so? Does anybody want to help out? Anyone who also thinks it's B?
I think it's going to come back first because with a set timeout of 500 milliseconds, it will come before the 1,000 milliseconds.
Yeah.
Based on the set timeout.
Exactly. So now B will come back. So after C has finished executing, B will come back before A. So let's proceed into just continue. So once C has finished executing, the event loop will go back into the task queue, take the next task it needs to take back to the call stack, which is B, finish executing B, then go back, check again as it loops the next iteration of the loop. It will check again, do we have anything in the task queue? We do. Put it in the call stack, then finish operation. Anybody with a question? Is it making sense?
Will function D happen at any time?
Function D already happened.
As the first one?
Yes. So let's do it again. So function D was the first one because function D is not, it doesn't have the callback pattern. So see, let's wake up for task 2. So it will be executed in the call stack by default. It's like having a console log. A console log that is not in a set timeout is going to be executed in the global, like just the main thread, the main pipeline. Same like for loops. So if you have a long running function D, it's going to block the call stack. Like if you have a for loop that goes into infinity, it's going to block the whole call stack. So function D, because it's not inside of a set time, it doesn't have the callback pattern, itawekwa kwa call stack. So if we run it again, if you check the first time we run it, the very first time when we run the program, you will see when we step into it, first of all, task A, the function A is put in the task queue, then B, then C, right? Then what is executed in the call stack? It's function D.
Oh, nimeona hiyo.
So D comes, then ikimaliza kuexecutiwa inatolewa, then C comes sasa. C comes in sasa. And then B, and then A, and then the program inamaliza.
Yeah, I have a question.
Mm-hmm.
What about like a set immediate? How will that behave in this context?
So a set immediate, same thing. Because
Yeah,
even a set immediate is still a timer function. So all timer
like
functions.
will it come in before the set timeout with 0, or will it be the first one to go there?
Let's see. Let's first of all put the set immediate huku chini. Okay, so let's see what is going to happen. Okay. A, B, set immediate is not defined. Nimeandika aje?
Haichukui milliseconds.
Yeah, it doesn't take anything. Seems that like there's an issue with the, let's try it in the console. Have a set immediate. I don't think we do. Do we?
We do, or maybe it's only in Node. So I'm not sure whether it's in the browser, but it's there.
It takes in a callback function.
Yeah, it takes in a callback without the time.
Ni kama haiko kwa, it's not an implementation of the browser. Maybe let's see. I don't think we have anything here that. Yeah. It looks like it's only in Node.js. Okay, now that was a perfect segue into like looking at now a big difference between Node.js and JavaScript. And the fact that when we started the session, I said, like to become a set timeout, they're APIs, they're not part of the language. So you can see on the browser, set immediate is not available, haiko, but it's available in Node.js. So that was a very interesting question. So let's do console logs here. All see. A will be okay. So let's see how it will put them, how it will execute them. Okay. So this one is called fast. Set immediate is called fast. There's no waiting. So it's called even before set time out here 0. Okay, that's very interesting.
Yeah, it's interesting.
Yeah, that's very interesting. But it means, I think bado inawekwa tu kwa. Okay, so let's see whether it's being put in the task queue. Let's do this hapa kwa hii for function D. Let's console log something. So if function D happens before set immediate, it means that this is also still being put in the task queue. Because if you're calling it immediately, it should come back immediately, right? Yes. Also, it's bado inawekwa kwa task queue. Very interesting. Okay. Very nice question. I think we've been able to see.
But something's changed.
Where?
We called C before we called the immediate. And before set immediate was turning fast, I think. So.
What?
In the terminal, we have function D,
Yeah.
then called C.
Yeah. Let's try it again.
But when we didn't run the function, when the function didn't have a console log, immediate came first.
Move it again. When we didn't have the console, kama nisi hatuko tumeangalia vizuri.
Can you just comment out the console log then?
Yeah. It what?
Oh, okay, so.
Was it like this the first time?
It's actually changed. I think I've also seen like it's changed or something. The first time it called immediate fast. Don't know why.
What a very weird programming language. What happened?
Maybe you can scroll that terminal you see up there.
I have already cleared the terminal, so Haiko. I cleared the terminal.
Oh, okay.
That's very weird. But let's try to get it to do that again. I'll just undo. That point. Doing the same thing. Unless it's, I don't know. That's weird. Ama ni si tumeona vitu zetu. Does anyone else see what happened the first time? Called immediately came first. Or ni sisi tuliona vitu zetu. Who else saw that the first time we ran?
I also saw that. Call immediately went first.
And then called C. Sindio?
Yeah.
Wow, that is weird. I think we will have to do some research on that because I can't even begin to even think why it's doing that. So I'll go into tatafuta nione if there's an explanation for that, and then I'll tell you guys tomorrow. I didn't even know set immediate is not in the browser. Very interesting. So we'll for sababu ya time I'll look into it and then come back with an answer tomorrow. Okay. So that is that's it for what are they called? Callbacks. So callbacks are how we used to handle asynchronous operations in JS before promises. So before we had promises, that's how we used to handle asynchronous operations. But now since they introduced things like the fetch API, which now use promises, and promises, since they introduced promises, most people tend to use promises now. So there is a difference in terms of how they are implemented. And that difference is in terms of where they are put during execution. So now let me remove this set immediate issues. Remove this. And then let's go into one of the other examples. I think we go with the micro task. Okay, so now let's look at this example. So promises inawekangwa kwa micro task queue. So if I come down here and I have another function, or we can have set out here, and then have an anonymous function. So micro tasks have more priority than task queues. And then I'll also have one more thing here, just to have like a bigger picture. We can have everything sasa. I'm calling D, then let's execute D. Okay. We can see we have a fetch here, then we have a promise.resolve, then we're giving it the function to run, and then we have a promise.reject, then we're giving it the function to call when we have a rejection. So let's go through that process. Okay, started executing. So B is put into the micro task. Okay, now weird thing happened. How come A was not put in first? Okay, let's continue, talk about it later. And then C is put in, and then anonymous, and then D, right? Here, we still don't have A is still not here, which is being called with a fetch. Then we proceed, calling D, so we log that successfully. It pops it off. So this anonymous here is being called by the set timeout. That's what we call task queue. But the promises, the two promises, right, the function B and the function C are in the micro task queue. So because this one has more priority over the task queue, these ones will come back first. Okay, so question, which one will come back first between B and C into the call stack? Is it B or C? Who wants to try?
B.
Anybody?
B.
B, okay, B. Someone said B. Who else wants to try and see kama? So why
B
B?
as well.
So why B? Why do you guys think it's B?
Because it's first in, first out, and B came in first.
Okay. All right, so let's try. So B is put into the call stack. Then C is put into the call stack. Then anonymous. Then A. And then it's done. Now, the question is, how come set timeout right? Even though it was in the task queue, came before the function A. How come ilikuja mbele ya this one? It's because of the fetch. So the fetch has a lower priority than all of them. So let's try it again. Let's do it again. Because ideally, a fetch to do it take how long? We don't know how long it's going to take, even though it's a promise. So let's try it again. Let's start again the whole process. We go through it again. Okay, so we go through the code, puts in B, puts in C, puts in anonymous, calls D, puts it on the call stack, executes D, pops it off the call stack, puts in B, pops it off, puts in C, pops it off, puts in the anonymous function from the set timeout, pops it off, now puts A in the micro task. Because when you use a fetch, it has a lower priority than all of them. So even if it's a promise, but itawekwa kwa micro task, yes. But it's going to execute after the task queue because of some phases. The event loop has phases. So itawekwa mwisho. That's why it's coming last after everybody else has executed. Okay, let's look at another example. Tasks versus micro tasks. The same thing we're just from doing. But you see, this is just a promise.resolve. There's no fetch here. So let's have another function here, same function D. So let's run the code. Okay, so based off of what we've been doing, who can give us the order of things that will happen? So who will go into what will happen first? What will happen first? Who will go into the call stack first? Between all of them, between function D, actually forgot to call it. So who will go into the call stack first, then followed by who, by which function between A and B? So who goes first, who goes second, who goes third in the call stack? Anyone who wants to give it a shot?
I'll say D goes first, then A, then B.
So D, then A, then B. Okay, so D, A, B. Who else wants to try?
D, B, then A.
D, B, A. B, A.
I think it's D, then B, then A.
Okay, good. So let's try. So let's run. Go through it. A is put into the task queue. B is put into the micro task queue. D is put into the call stack. We execute D, pop off D, execute B, pop off B, then execute A. You can see, even though our set timeout is set to 0 milliseconds, the promise has more priority. So even though this one was to run immediately after the call stack is empty, right? It had to wait because there was something in the microtask queue. The promise, so the promise has higher priority. That's why we ran D, then B, then A. Is it making sense? So that's the main reason why. That's one of the reasons why you would want to use a promise over a task queue, maybe over a callback. Maybe you want some functionality to come immediately after the call stack is empty, but before a callback. Any questions? Anyone with a query? So we've already seen this callback pattern actually a lot when we've been writing code. So even without using the set timeout and whatnot, every time we use a document.query selector, and then we say, when you add an event listener, we normally have a callback function. So that is telling you that that's utilizing the task queue, because you normally pass in a callback function. So anytime we do something like document.query selector dot name something, add event listener. This pattern of click event and then a callback function, same pattern, right? We're passing in callback function to our add event listener. That's because we don't know how long whatever operation is running here is going to take. So it makes sense to do it asynchronously. We don't know whether within the click functionality, you're doing a fetch request. We don't know. So we don't want this to block the main thread. So you give that functionality to the event loop, which gives it to the task queue. And then it will come back to be executed afterwards once the call stack is empty. Any question? With a question. All right, so now let's do like just a few examples.
Ian,
Mm-hmm.
kuna questions kwa chat.
Oh, there's questions in the chat. Okay. Okay, so priority and the promises part, and I can see Catherine also shared something in the chat. Catherine, did you get that from, you Googled it? Execution order will depend on various factors, but they will both run in the next iteration of the event loop. Okay. Then Mambo, set immediate, current. Okay, Sawa. So I'll repeat the promises part, and then the priority levels also. So let's go into the microtask. So I will remove this one for clarity. Nitatoa hii ya fetch. Then we simply have promise.resolve, and then .then. We simply pass it in a function to call, because we're just resolving the promise immediately. We're not doing at a .catch whatever. We're just doing it immediately using the promise object. So promise.resolve, and then .then resolve with function B. Then promise.reject, and then catch the error with function C. Then down here, we'll have set timeout, go back, 0, console.log, hold after 0 milliseconds. Then we will have console.log. Let's play around with them a bit. I will be logged. Then let's have a function B, and console. I will be logged from B. Okay, so now let's go through the process. We start execution. Actually, wait, I did not forgot to execute this, invoke it. So we've invoked it, so let's start. So let's step through the code. So micro task, we have the function B here, it's put into the micro task. Then we have function C, which is the next line put into the micro task. We should have now an anonymous function put into the task queue, the set timeout. Then we should have D, right, put into the call stack. And then we log that value. Then we say I will be logged, because in this case, remember we are running synchronously at this point. So D has to be executed before console log is executed, right? So that's why this one came after we executed function D. So D has been popped off. Then we executed console log, which is being done by the global execution context. Finishes. And then now the call stack is empty. So now we need the things that we have pending to come back into the call stack. So the event loop will check, right? Do I have anything in the micro task queue? If I do, and the call stack is empty, I will put it in the call stack. And then it will check again. Do I still have something in the micro task queue? If I do, check the call stack, make sure it's empty, put whatever is in the micro task in the call stack, execute it, and pop it off. Then it will check again. If it finds the micro task is empty, now it will check the task queue. Now it will check, does the task queue have anything we need to execute? If we do, it will take it, put it in the call stack, execute it, and pop it off. So let's go through that process. So now it will see we do have something in the micro task, put it in the call stack, execute it, finish, pop it off, check the micro task queue again. Do we have anything? Yes, we do. Execute it, finish, pop it off, check the micro task again. We don't have anything, so now it checks the task queue. Finds something, puts it in the call stack, executes, and removes it. Called after 0 milliseconds. And then pops it off. So the micro task has more priority than the task queue. When you use a callback function, your operations are put in the task queue. When you use promises, your operations are put in the micro task queue. I don't know whether I have cleared any confusion, any question. Catherine and Davis, is it a bit clearer now?
Question, Bado. Yeah, micro task, the call stack and the task, those go sawa. When it comes to ipande ingine promises, set timeout, and function ingine, function D in this case, hierarchy hapa inaenda aje? Because on the other side, micro task is given a priority. Hiyo sana ni number 1. Ipande ingine, promises go first.
Promises
then fetch goes last.
Then fetch goes last.
In between sasa hapo ndio kuna
so fetch will always go last. So even if you have, so from the example we did, the one that they gave us, so fetch will go even after the task queue. So hata kama ni a promise. So let's go back to that example that they gave us. I think it should be this one. Yeah. Wacha tuirudi vile ilikuwa. And then let's edit hii code. I'll just copy paste one of my functions from here. Okay. All right, so where's the confusion now with that code? Vile iko hivyo. Wapi na confuse? What should I add to make it a bit more clear?
Set timeout.
Okay, set timeout. Do I have any set timeouts? Don't want to rewrite that. Yes, I did. So we call set timeout to 0 milliseconds. Let's see. Okay, let's run.
Yeah.
B.
Renamed the set timeout function because it's C and we already have another function.
Oh yeah. I need to rename this. But let's see what will happen. Let's see. Let's try to break it. Because now we have two C's. Let's see what happens. C, which C is that? It's the promise one. It's fine because they're different. Because this one is being called by the set timeout and the other one is being called by. But okay, just for clarity, basi nitaweka tu different letter. Start executing. Execute. You can already see the fetch. It's like it jumped over it. It's not even putting it in the micro task. Imeachana nayo. And then we move on to C. Then we move on to the set timeout. We put in the function F. And then now we go to D. So D is put in the call stack. Up to that point, Davis, are you okay? Baka hapo.
Okay. Issue ilikuwa hapo katikati. Ya kwanza na ya mwisho iko sawa. Katikati, that was the...
Okay, so we continue. Let's go. Mali utasikia ime confused utaniambia. So let's continue. So we've removed D. So now who are we expecting back in the call stack? Who's coming back so easy based off of what we have? Who's going to come back to the call stack between B, C, and F? Anyone who think which function is going to come back first?
Let's say B.
Which one? Which one?
B.
B. So B. So let's execute. So B comes back, executed, finish, popped off. C comes back, executed, popped off. Then F comes back, executes, gets popped off, logs called F, inamaliza, pops it off, now puts A. Now is when it's executing A. Let's actually do something interesting here because I'm also curious. So let's go into this hapa, and even if we tell it to wait 5,000 seconds, then we run it. Okay. B, C, F, D, execute, B, execute, C, execute, A. Okay. Did you see what happened? Can we do it again? Let's do it again. Telling you JavaScript is just like, it's one of those very dramatic languages. So let's do it again. Okay. B, C, F. Up to this point, this is the normal behavior we've been seeing, right? No changes. B is executed. Then C is executed. Then A is put into the call stack. So now, in terms of the priority, do you think anything has changed here? How come now we are going to execute A before F? Because A goes into the call stack, then F comes into the call stack. What did we change? We just changed the number here, the number of milliseconds to wait from 0 to 5 seconds. And that has completely changed the behavior. Because now when we get back when the microtask for the fetch comes into the microtask queue, it executes before the task queue. So based off of what we can see, it looks like when your set timeout, if you have a callback function that is set to 0 milliseconds, it gets executed before the fetch. But if you have a set timeout with more than not 0 milliseconds, it gets executed after. So let's try to confirm that again. So let's, instead of 5,000, what are we party 1 second only? It's going to make a difference. Okay, let's run it. B, C, F, okay, D, execute, pop off. B, execute, pop off. C, execute, pop it off. A, execute, pop it off. F, pop it off. Let's take it back to 0. Run it again. B, C, F, D, pop off. B, pop off. C, pop off. F, pop off. Then A, then finishes. So we have discovered something. So when your set timeout has something other than 0 milliseconds, the fetch is executed fast. When you have 0 milliseconds, then the set timeout is executed before the fetch. What a dramatic language. Can you see what is going on here? Davis, are you still confused?
Nimeelewa sasa.
Meshika?
So tukiweka set timeout mbili, one with 0, the other one maybe with like 5,000.
Very good question. Let's do that. I like your question because so let me just edit. Then let's set this one to 5,000. Then 100. Let's see, because that's less than a second. Okay, so let's do this. Let's go into the execution. B, C, F, so the other F, I didn't change the name, so let me just change it. We can start again for clarity. Chatuweke equal E. Okay, then let's run it. B, C, F, E, D, pop off. B, pop off. C, pop off. F, called popped off. A, call stack, pop off. E, pop off. Have we answered your question?
Pati ya mwisho sijaona.
Jana pati ya mwisho.
Ni step pole pole.
Okay, sasa tufanye tena pole pole. Haya. So first microtask, the B, so this huyu hapa, and then we put the C, the second projection for this promise, and then F, which is the set timeout, the first one, then E, which is the second set timeout function, then D, which is put on the call stack, executes it, pops it off, then B comes down from the microtask, gets executed, gets popped off, then C comes into the call stack, gets executed, pops it off. Now, the next thing that is going to happen now, F is set to 0 milliseconds, and E is set to 100 milliseconds. So let's see what is going to happen. Pop it off. So F is put into the call stack because F is running immediately. So you can see we still don't have the fetch. The A bado ijakuja kwa microtask. It will now come after F has finished executing. Ndio sasa imekuja. Then execute it, pop it off, then execute E. And pop it off.
Understood.
Understood. Okay. Anyone else? Anybody else? Are there any questions in the chat I have not seen? Na mtu amekwama mahali. Okay, sawa. Okay, a bit clearer. Okay. Now, we were supposed to talk about Node.js. Let's see if we have time. I don't think we have enough time, but I'll just show you just a bit and then tutaimalizia kesho. So when we talk about, and Joseph was explaining what Node.js is, you can see we have not moved files, they're just in the same app.js, the same thing we were using to run our HTML, CSS, yenye natumia kwa browser. The only difference is the Node.js does not have the DOM. So you can't say window.something. You cannot say document.getQuery select as because servers don't need the DOM. What servers need are things like file systems, operating systems, like ISO information. That's what servers need, because they read, they write to files, and so forth and so forth. So I'll just put it in another file here. Even if I was to put it in app.js, bado ingework. So for you to get Node.js to work, you need to have it installed in your machine. You can see I have version 18.13.0. So what Node is, it's a JavaScript environment. It's simply a place where you can write JavaScript outside of the browser. Now, the browser, the browser console is also a JavaScript environment. And I will prove that to you right now. So if I want to start Node, I simply type Node and I press enter. I'm now inside of a JS environment. I can write JavaScript here. I can say let name equal to Mike, press enter, and I can look for Mike. First name, sorry, I can look for first name. You can see we have Mike. Let me make this bigger. You can see I have Mike. So I've been able to successfully create a new variable called first name and set Mike to that value. And then I can now call first name and I get Mike Apachini. Now let's look at the console. The browser console is not something that was there kutoka kitambo. It was introduced later on. Nimesahau kwa which versions of Chrome and Mozilla. This thing here is the same thing as this thing here. In terms of, it's an environment where you can write your JavaScript. Because if I do the same thing, utona, they look exactly the same. If I say let first name is equal to Mike, and see same thing. Hapa tulisema let first name equals to Mike. When I pressed enter, ikaleta undefined. Hata hapa pia imeleta undefined. Then if I now say first name, you can see I'm getting Mike. Same thing. So these two things are JavaScript environments. So in Chrome, it is using the V8 engine to consume JavaScript. The same thing that Node.js is also using to consume JavaScript outside of the browser. So what the guy did, the guy who created Node.js, he simply alichukua tu your JavaScript ilikuwa kwa browser, and since V8 is just a C++ application, he now made it possible, right? So your V8 plus JavaScript, and then he made it possible for you to install it on your machine or Windows. So he just plugged it out to our browser, akaiweka kwa operating system. Because C++, which is used to write the V8, is just an application. Sini up to ya kawaida, you can write an application using C++, kama any C++ developer, that runs on Windows, macOS, and all those other platforms. So that's why it's working. So ilikuja pamoja na APIs zingine, because we don't need the DOM, we don't need to carry the DOM into Node.js, but we do need other APIs, other functionality that are unique to servers. So because I know I have Node.js installed on my machine, we have things called modules. So you've seen this with React. So anytime you hear someone saying, Kama Joseph last week was saying that, for example, React.js, they are just node projects. So for you to have a node project, one of the first things you need to do is you need to say npm init, initialize a node project. And then it will go through a few things asking you, what do you want to, what configurations do you want for your application, like name, description, what license. So if I press enter, you can see it's taking me through what is my package name. You can say the event loop because it just picked it from my file name. Let me make this bigger because I think I'm done na hiyo ingine. So we want, okay, package, we want the package name to be the event loop version 1 description. I will not give it a description. Entry point, I want server.js. First command, not now. Git repository, not now. Keywords, not now. Author, I can say Ian. And the license can be that. And then it asks you, is that okay? Is that okay for the package.json? So if you've written React code, you have seen a package.json file. That's the same thing it's going to create. If you look here, it's going to create a new package.json file. I press enter to your Yapa. If I open it, it has all our configurations and tumesema when we are now creating it. So this is that package.json that you normally see coming with React and so forth and so forth. And then now, if I want to, for example, you can see right here. So when you're running a React application, you normally say npm start, npm run dev, npm blah, blah, blah. It's these scripts here, easy. So it's telling us if we want to start the application, the node application, you need to run npm start, which will now run our server.js. If I simply come here and say server running, two ways of doing it. You can either say node then give it the name of the file you want to run. In this case, server.js, we have server running, or you can use the script it created for us, which is start. So you say npm start, and it train the server. Right here, server running. So you can see this is just normal JS upper. There's no difference here. This is just normal JavaScript console log. Now, it comes with a few packages by default. So for example, by default, Node uses something called CommonJS. CommonJS, I think, came before ES6 modules. So if you've ever seen any Node code, maybe you might have seen this syntax: const fs is equal to fire fs. So this is CommonJS. This is what is called CommonJS. When you're using import, that's ES6. That's now ES6. Now, if I was to come here in the console log fs, I'm going to print out a very big thing. These are all the functions that are available to us on the fs module. And fs module is responsible for file, it's called fs is file system, the file system module. You can use it to read files. You can use it to write to files. You can use it to do literally anything that has anything to do with files. We have another one called path. Because I have Node.js installed, these packages come with Node.js. I don't need extra functionality, so I'm just using whatever packages came with Node.js. Path is now used to find different paths. So for example, I can say path.solve. And if I come here and I run, we just use Node for now. And see, it's giving me my path right now. It's telling me where I am in the computer. You can see the same thing that we're getting Hapa Ju is the same thing we're getting Hapa without obviously the node. So we are resolving our current path. So you can think about it this way. If you now wanted to create a new file or a new folder within this directory, you could do that because you know the path. You know where we are. But you can also use modules. So the way to do it is you go into your package. There's two ways of doing it actually, but I'll show you the easiest. You go into your package.json, do right here. Come here, you tell it the type, the CommonJS or module. I want modules. And that's it. So now if you go into the code and we change out these values, now import fs from fs and import path from path. Still works. If I say console log fs and try, let's use path because fs was giving us a very big thing. See, same thing. Does anyone have a question to that point as to in terms of Node.js? But you can see it's just JavaScript, JS too. Now, let's do just one example of synchronous behavior, like asynchronous. So I am going to create a new file here, text.txt. Then I can say this file will be read by Node. Now the fs module gives us a method that we can use to read files. So we can say fs.read file. Let's use sync. And the path to the file, we know the file is in the same directory that we currently are in. So we can just say text.txt, and then the encoding, character encoding. We have ASCII, we have UTF-8, we want to use UTF-8. Then let's simply also log this value. You can see this is just normal JS. This is just a normal function. A method you're taking, the method is taking in two things: the path or the file you want to read, and then the encoding, the character encoding. You can see it has read the file for us, saying this file will be read by Node. Now, let me show you what synchronous and asynchronous means in JS, in Node.js. Still the same thing. So hapa chini, we'll say this is a console log. Okay. Fine. Nothing unexpected there. Now, if you look at this function, we have read file sync. So this is telling JavaScript Node.js that you should read the file synchronously, not asynchronously. So line by line. So don't go to the next line until this has finished executing. So you can imagine if you had a file of like 1,000,000 words, your line on line 5 would have to wait until the program has read everything before it executes. So it will block everything else. So we have another function available to us. So other than read file sync, we also have read file. So read file, we'll do it asynchronously. It will take an extra argument, which is a callback function. Same pattern we've seen in the front end. And then it takes in two things: an error, so if something happened, and the data that we get back. And then if we have an error, we console log, we could not read the data. Else, console.log data. I will comment out this one ya kwanza hapa, hii read file sync. Actually don't need this also because we are console logging within function. So now the only difference between this na hii ingine ni read file sync does not take in a callback function, it simply takes in the path and the character encoding. But read file, which is asynchronous, it does not block, it's non-blocking, doesn't block. It takes in the path, the character encoding, and a callback function. So now, initially, this is the result we were getting. This file will be read by Node when we used read file sync, and then we would get the next line, which is, this is a console log. I will leave this here, and then now we will execute it again. And see, the order has changed because it's using the same principles. Because it has identified that this is an asynchronous operation, it knows it needs to handle this in the task queue. So anything else that is not to be handled that way is going to be executed first. That is why this is a console log came before the actual contents of the file, which is here, the data. So same behavior we have seen in the front end. Any questions? What do you think? So you see Node.js is not so different from, actually the same. It's just that you have a few more methods and functionality that you don't get from the browser, and vice versa. The browser has functionality we can't get in the for servers.
Could you explain that event loop that's happening in this function again?
So to visualize it, it's the exact same thing that we were getting with, where is it? With this one, we put them side by side. Okay, so now this behavior that we get from Node.js is exactly the same because the event loop is the same. It's using the same event loop. This functionality that you're getting here, right? Obviously, I can't paste it into this because this is the browser. The browser does not have an FS module. But the way to think about it is, if I was to again go into the task queue, and then I simply remove this, and then I have my, let me see how I'm going to mimic this. Just a set timeout will still work. It's exactly like a set timeout the way we were using it. Set timeout set to 0. Then you have like a console log hapa chini. This is a console log. Then console log data from the file. So now I will try to use this to explain this. So in our console, when we run it, first of all, this is a console log, and then we get the data, right? That's because the same way hapa, if we have a set timeout set to 0 milliseconds and we run it, even though we are supposed to run this thing immediately, right? Hata kama tunafaa kuirun immediately, it's still going to be put in the task queue. Same with this, the read file. So hata kama hiyo file iko na one word, even one letter that it needs to read, that will take less than a millisecond, it doesn't matter. It's going to be put in the task queue on Node.js sasa. And then it's going to continue with the rest of the program. That's why this is console log will log first, because this functionality for read file is asynchronous. So that means because it has seen the callback function here, it will now put this functionality down near the task queue and wait, and only bring it back when the call stack is empty. So if you walk through it, itafanya the same thing, exactly the same thing. It will put this arrow function here, this anonymous function, ndani ya task queue, and then proceed with the program, which is console logging. Then it will console log. That's why we get console log first. And then once the call stack is empty, it will now bring back the response from the read file. And then now log that data from the file. And that's it. Did I answer your question, Catherine?
Yes.
Okay. Anyone else? Okay. We have extended, but it's okay. I think we have done a lot. So I think tomorrow we can do more examples of Node.js. It has like very interesting things that can show you like how, for example, like real world applications actually work. Like it has a module called it can consume things called streams. So if you have a very big file, like file ya 1 GB, it does not like read all of it at once. Vile torrents zi work, it gets inazipatanga in bits, kidogo 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 paka inajaa. Torrents actually work the same way. Alafu pia when you're streaming something, hata YouTube, what normally happens is it doesn't download the whole video at once, does it? Kama ushaona kale ka gray pale chini kwa YouTube, doesn't download the whole video immediately. You download bits by bit by bit by bit. So is that streams working? We'll have a look at them kidogo tomorrow and see what they do. Okay. All right. Okay. So tomorrow we'll continue with the same. We finish up, and then now once we finish up on Node.js and that asynchronous behavior, we'll now go into regular expressions. And then now once we're done with regular expressions, I think we'll maybe Friday, we'll just take some time to go through all the material we've been going through, or maybe we won't even have a session. Maybe we'll take a break because we have been covering a lot over the last 2 or 3 weeks, because we did object-oriented, and then we did ES6, and then now we are doing like asynchronous JavaScript, and then next week we'll do functional programming. So you see, it's like heavy hitters. So once we are done with mwisho, we now just focus on ISO projects, HTML and CSS to finish them, so we can start the next cohort. All right, so thank you guys for joining. I hope you've learned something today. And I'll see you guys in tomorrow's session. Enjoy the rest of your evening. Bye.